Alright guys, welcome back. We're going to be solving another question from the second chapter of Engineering Mechanics Dynamics by Meriam, and we have a question from the second chapter, and we need to determine the velocity of cart A if cylinder B has a downward velocity of 2 foot per second. So as we can see in the figure, we have the velocity of B 2 foot per second at the instant illustrated. The two pulleys at C are pivoted independently. So the two pulleys that we see at C, the little one and the small one, are independent of each other, meaning they're not affecting the rotation by any means. And we solved a couple of questions in the previous videos. Basically, we have one single cable in these types of questions that goes around all these pulleys, and obviously the length of this cord or cable is constant. Let's just call that L. And the way we're going to consider this length, now we're going to break it down. So if we just consider from center to here, this distance, we can call it anything SA, YA, or any other variable. So let's just call SB, which is the distance that the cylinder B is traveling. And we can see that we have 2 SB here, and if we go further, get to the cable that is between the two pulleys right here, so we're gonna make an assumption that all these three are also parallel to each other, so we don't need to consider any extra length in here. So we're gonna call this one SA, and basically we have 2 SB plus 3 SA, and we're gonna have some constant, which are those that are going around the pulley, this part, and this. Have a little part in here, and this one. You can just call these constant just as it is, constant. And the question is asking for velocity. We know velocity is derivative of the distance. We called it s in here over time. What we're going to do in here, we're going to do the differentiation on the side of this equation. So obviously L is constant. Differentiation of the constant over time is going to be 0. For this part in here, we're going to have 2, which is our constant. So no change to that one. dSB over dt, which is going to be the velocity of B plus 3 dSA over dt, or derivative of the distance with respect to time, VA, and another constant just like L, that's going to be 0 too. So now we have the relationship between VB and VA. And from the question, we know VB is 2 foot per second, so our VA would be -4 over 3 foot per second, and that's going to be -1.33. Repeating, foot per second. And keep in mind that since our starting number is 1, we need to go with 4 significant figures. As we talked about, for engineering problems, we usually go with 3 significant figures unless the number starts with 1. And for that, we go with 4 significant figures. And the negative sign shows that the direction is the opposite. So once this cylinder goes down, the cart A is going to go up the incline. And yeah, that's pretty much everything for this one. Hope everything is clear. Let me know if you guys have any questions. You guys take care. I'll see you in the next video. Have a good one.